Okay, so for this week's lessons, we're doing kind of a deep dive into materials. So I've made these videos to be smaller, sort of bite-sized chunks. So this first video is just going to go over the differentiation between the different major materials in Maya. So I've set up a little file, which you can get online, although you need the whole project if you want the labels that are here. Set up 5 identical spheres. They're using the exact same color, but they are obviously 5 different materials, right? And we've talked before about the fact that the difference in the materials is the difference in the specular highlight, or in the case of a Lambert, lack thereof. So there are a few settings on the Lambert Hands. Open up this, there we go, that we can deal with and that we will deal with in later videos, but honestly, this one is just here as a control. um, and the other thing to let you know is that I did put an actual light in here so that in some ways things will be consistent, because otherwise, yeah, there we go. The specular highlights would follow us around, and we kind of don't want that. That's not to say that the placement of the camera doesn't matter for the highlights. It will. It's just that it's a little bit better to show things when you have an actual light in here. So we got the Lambert for control, and you can see it's brighter on one side and darker on the other, but otherwise there is no highlight. And we have talked before about these highlights, but we kind of want to drill down into the specifics of this. So we're going to also ignore anisotropic for a moment and talk about these 3. So when it comes to your specular highlights, the gold standard is actually the blend. So if you take a real close look at it, you can see there's a hot spot there, yes, but by default, it's got a pretty slow like drop off. And so it's got like this very much softer one. The 2 Fongs, there are settings we can change to make these much better, but essentially this is a tight little one that doesn't travel nearly as far around the object as the blend. And then this one is obviously it's much larger, but it's almost like a spotlight where you didn't like handle the edge correctly. And so it's just bam, it's there. Now, part of the reason for this is that the highlights are all white. We will also deal with changing the color of the highlights in a later video, but this white helps us see exactly what's excuse me, what's going on with the highlights, makes it very clear, right? Now, why would I have these 2 things at all if the blend is so much nicer? Well, for one thing, these are cheaper to render. So the reason the blend looks nice is because it's more render heavy, right? There are also completely different settings to each of these. So a regular Fong is going to have these things right here where there's something called a cosine power. Everything has a specular color. Everything has a reflectivity, and everything has a reflected color. We will get to those later. The only thing that the Fong has that the other ones don't is something called a cosine power. And if I move this here, see, I can almost make it look like the Fong-yi in some ways. This is basically the size and shape of the highlight. So if I turn this off, it's a very pinpoint highlight. If I turn this all the way up, it's a very broad highlight. And we're going to tinker with that when we get to the specular color in a little bit. I'm going to put this back to the default. But that's kind of like the only control it has that's separate from the others. Here with the Fong-yi, a little bit different. We do have, again, specular, these last 3, always the same. It also has this whiteness feature right here. And this also feeds into the color of that highlight. So if I have a few pre-picked colors that get saved in here. All right, so we can kind of change that, but that's not really where the power in this one is. This is having both the size right here and the roughness. This is, if you're remembering your lighting and the way the spotlight works and the fall off from there, yeah, similar idea. So I'm gonna turn this back to white just so we can make comparisons. But we can change that roughness to kind of start to approach this. Not exactly. Even if we change this color to be a little bit closer to the actual color. All right, now we start to get a much softer highlight. So you can make this, cheaper renderer work for you, but there is some stuff that we have to do besides just the size and the roughness over here. With the blend, we come over here. Again, those same three things. And there's actually, it's deceptively simple. The eccentricity is basically the amount of that highlight. So we can make it a much broader highlight, or we can make it a very pinpoint highlight. And these highlights, by the way, determine what we think the material is. Entire tomes can be written about this. Now, there's no real way to control like the fall off on this, right? We had that on there. On this, they're just like, no, we got it right. it's a nice fall off, so it's gonna stay there. The specular roll off, this has to do with reflectivity a little bit. So it is changing how this looks, but you're never gonna have sharp edges like you do on the others. And you're never gonna have, that look. So it is affecting the amount as well, but it also has to do with its interaction with other objects, which we wouldn't see until we rendered. All right. Can I undo this? Get back to where I was. There we go. Now, so they all have different settings, but in the end, those settings are dealing with the size of this highlight, and in the case of these two, the shape of, or actually in the case of just this one, the shape of it a little bit, like the texture to it. Anisotropic has a whole different ballgame in mind. So, excuse me. So, I'm never going to pronounce this correctly. Anisotropic deals with surface direction. So, first of all, if we do this, the highlight changes. That is not going to happen on all of these spheres. Nope, nope, nope. But it is looking at those edge loops. It will also deal well with, if I move these down. That was a terrible way to do that. Stand by. All right, so I added a bit of modeling detail into there so that we can kind of see what anisotropic deals with. So it deals with surface direction, and it deals with things that have sort of more wrinkles in them, but it also has all of these settings here that can help you define what that means. Let me go back here. So you see I changed the angle on this. It is sort of making up a surface texture, is how I would simply describe it. If you think about something that's like feathers or a CD or something, there's technically like grooves on it. And so this determines the direction of them. There you have it. Now, there's a seam here now. So we would, I suppose, want to be hiding that seam somehow, and also not modeling a sphere like this in the first place. This is one of many reasons why you wouldn't model something in this manner. But yes, we can change the angle of those sort of fake things that are on the surface that we can't actually see. We can change the distance between them. There we go. And then the roughness, just like on the one Fong one, is sort of like the amount. So if this changes the direction and this changes sort of the distribution, then this changes, once you have that pattern, this roughness changes the overall amount. And so you can make something look like a hard shiny plastic by turning down that amount, or turning up. Yeah, I turned it up. Nope, just kidding, I turned it down. Or if you turn it up, give it a softer look. Come on. Now it's very glossy. So This is by far the most complicated one. We've also got this, I'm going to pronounce this wrong too, Fresnel index. There we go. Sort of like a softer, there it is. Now it's not so sharp and glossy. Again, same specular color. There's no reflectivity on this one. We got that same specular color that we can change. That again, we're going to do that in the common things video. All right, so those are the main differences between these materials. Now, I said before that the highlights and lights and direction, we're dealing with light, so surface direction matters and direction of camera to light matters, and nowhere is that more clear than if I also put up some cylinders. So these are cylinders with the exact same materials as their respective spheres. And you can see what a difference it makes. First of all, there's nothing going on here because there is nothing going on here, right? If I wanted that to have anything, I would have to actually place something on there. Maybe it catches the top a little bit differently, but if I add a little bit of geometry, all right, so we add a little bit of geometry. Now suddenly we're getting some results. So your same material will react very differently to different shapes, or not. This blend is looking fairly similar. Obviously, a highlight on a cylinder is going to be different than a highlight on a sphere, but it's looking kind of similar. I found this one the most interesting result. Part of this is a result of the directional light that I have on here. When I had it pointed down further, which kind of put the highlight at the top of the spheres, you actually couldn't see anything on this one, but you could on these two. And then also the cylinders seem to be a little bit more affected by the direction of the camera than the spheres are, because the specular highlight is also about the light hitting the object and then bouncing off and being directed at the camera. So unlike our Maya camera, where the specular highlights they are affected by the camera distance, but also they kind of follow us around in direction. These don't follow us around in direction, but it does matter where the camera is. We're using our little tumble around camera here is exactly the same camera you would use to render. All right, so the shape matters, not on Lambert, but on the others, the shape matters as well. So don't be surprised if something you come up with for a highlight over here works differently as a material on something that is a completely different shape. All right, but the other videos will go over the more specific, the things that are constant throughout all of the materials.